Hi guys, so this is a video on the Pythagorean theorem, which you can review if you missed the class or if you're unsure about it or if you're just preparing for the NJSLA. And the Pythagorean theorem is used to help you find the missing side of a right triangle. And it's important to only use this for a right triangle, which I have here because it has the little 90-degree angle with the two legs. So when we're looking at a right triangle, if we look at the side C that I have here, that's the longest side, and that's what's known as the hypotenuse. So if I don't know what the hypotenuse is equal to, I can use the Pythagorean theorem. And the Pythagorean theorem states a squared plus b squared equals c squared. And we remember that when we're squaring, we're multiplying that value by itself. So this is like a times a plus b times b is equal to c times c. So with the Pythagorean theorem, typically you're given two number values for two of the sides, and then you plug them into this formula to find out what the value of the remaining side is. So if we look at this example, find the value of x using the Pythagorean theorem, which, as I said, is a squared plus b squared equals c squared. So if this is a right triangle, then I have my sides a, b, and c, which in this case is x because we don't know what number value it has. Then I can take these numbers and plug them into my formula. So that would become 3 squared plus 4 squared is equal to c squared. So I know 3 squared is just 3 times 3 plus 4 squared is 4 times 4 equals c squared. So I get 9 plus 16 equals c squared after I simplify that. So now I'm left with 25 is equal to c squared. The inverse operation of a square is square root. So I'm going to employ my radical to get c by itself. So now my answer is c is equal to 5, and that is the value of the missing side. Let's try another one. So here we have a, b is the unknown value, and we are actually given the length of the hypotenuse, which is now 5. But we can still use the same formula. We'll just have to mess around with it to find out what the value of b is now. So if I plug in my values just like I did before, 4 squared plus b squared equals 5 squared, because we know the hypotenuse is 5, then I come down to 16, which is 4 squared, plus b squared equals 25, which is 5 squared. And now I just treat this like I would solving any other equation, where I take away 16 so that I isolate b squared. Take away 16 from each side, I'm left with b squared equals, oh my goodness. Sorry, my pen just stopped working. Okay. B squared equals 9. I get out my radical again. B is equal to 3 because the square root of 9 is 3. Okay? So here's another one where we have to find the value of the hypotenuse. Again, why is this not doing what I'm telling it to? A, B, and C. I know that A is equal to 5, B is equal to 12, and we're missing the value of the hypotenuse. A squared plus B squared equals C squared. And I can use this, once again, because this is a right triangle. So then I plug in 5 squared plus 12 squared equals c squared. And I know that if I flipped it around and said 12 squared plus 5 squared equals c squared, I would still get the same answer because addition is commutative. So 25 plus 144 is 12 times 12 equals c squared. So then I do 144 plus 25, I get 169 equals c squared. Now, you'll probably have to get out your calculator for this, as I am doing right now. And then we get 13, well, we have to take the radical, square root it. C is equal to 13. So now let's try one where we have to do a little bit of problem solving. So here I have two right triangles, which are stacked on top of each other. And this is similar to the problem where we saw in the worksheet that said, like, find the distance across the river or something like that. So if I have two right triangles, this is going to be the hypotenuse of this triangle, and this section is going to be the hypotenuse of this triangle. So it's like I have A1. This whole thing, this whole section is 6 meters, which means that one segment will be half that, so 3 meters. So if I break this out into two triangles, it would look kind of like this. 4 meters, 3 meters, and x. That was terrible. 4 meters, 3 meters, and x. I'll do x1 and x2. But I can still treat this using the Pythagorean theorem because I have a, b, and c. So a squared plus b squared equals c squared. And also I know that these triangles are congruent because they have two sides that are the same length. And so therefore I know that whatever I find for the hypotenuse of, like, the top triangle, if I double that, it will be the length of this entire blue line. So I plug in 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. I did that wrong. 25 is equal to c squared, which means that 5 is equal to c. So this portion is 5 meters. If I double that, I know that my entire blue line is 10 meters. And that's really sloppy, but you get the idea. So if you have any questions, feel free to go through this again or ask us in class, and make sure that you practice before the test.